I was just going to sort of introduce the idea of the panel, and the topic is, can ICN architecture solve hard problems in network security? And unless you've been hiding under a rock the last few years, I think we all know that network security has some real issues. I mean, everything's getting attacked, right? I mean, really critical infrastructure in the US on the East Coast, and people's, this whole camera attack where the people were able to, go into offices, including Tesla, and see what was going on, and the things with baby monitors, and there are a lot of real world issues out there. And I think the question is, we know that there's this thing that we all say, oh, there are these security, it's more secure for ICN because we require signing or some such thing. But I mean, my questions would be, is it really more secure, and can we do anything with that? Does it really help us out, or what could we do that might make things better or be helpful? Or, if you're a complete denier and you want to say, we should all go home, that IP solves it, that's fine too. But I think one thing that would be really good to get out of here might be some guidance for, a lot of the researchers and grad students in the office, in the meeting. They might get some ideas of things they ought to look into in the future. So I'm going to go ahead and get started to see what the panelists have to say, if that's okay with everybody. And our first panelist is Eric Osterweil, and Eric is an assistant professor in the computer science department at George Mason University. His research focuses on large-scale trust and cryptographic key management. He was previously a principal scientist at VeriSign, and he's the former vice chair of ICANN's second Security, Stability, and Resiliency Review team. And I wanted to say that Eric did some early security work for CCN and NDN, and he's been responsible for DNS security enhancements. So he's a guy with a lot of background. So Eric, your turn.
Thanks. Yeah, I didn't want to go long in the intro of stuff to say, but yeah, I've sort of poked around with a lot of stuff, from DDoS to large scale key infrastructures and stuff like that, especially when I was at VeriSign. So yeah, I think not surprisingly from that intro and a number of the things I've done, my personal view is that the promise of NDN still remains like extremely large. And I think it's really good to sort of really beat on a number of different things at the same time. So I'm going to be a little bit maybe all over the map with some of the thoughts I put together ahead of time, but maybe that'll sort of distill well with the rest of the panelists. But I think not surprisingly, I think keys are the real key. I think that's something that's really important to get right for a lot of the security protections that we need in a lot of different ways. And some of the things that Kathy was just mentioning about security exploits we see in the wild recently, I think a lot of places, good, proper key management and hygiene solve a lot of those problems. We just don't do a very good job of it in, the current IP architecture. And so I would be really sort of like a big fan of underscoring the need to sort of have proper key lifecycle management built into a lot of the things that we talk about. So I'm excited to see a lot of the stuff that has been showing up in the ICN world around security recently. I mean, I really like seeing the attribute-based encryption work that's starting to percolate and sort of find purchase. And I guess what I would say is my view going forward is, while it's really important to do things sort of incrementally, big things start small, slow start, all that stuff. I think that's really important. But I think as a security researcher, it's sort of oftentimes forgotten that it falls to us to also present the motivation. In other words, you have to think big, and you have to communicate to people what the big advent is. What is it you're shooting at, even if you're going to make small steps going forward? And and I think, there's lots of ways I could illustrate that with anecdotes and examples, but I'm a huge fan of a very old proverb that is, to know the path ahead, ask those coming back. So while looking at things in the IP architecture that we're not big fans of, I think it's important to really understand what has and hasn't worked. And I think that provides a really solid, a valuable substrate for presenting what you think should come next. And so I could go on and on, Kathy, but I think that's probably a good enough intro.
Okay, that's great. So now we're going to move on to Ned Smith. And at Intel, he's the principal security architect in Intel Software and Advanced Technologies Group, and he co-chairs the Remote Attestation Procedures Working Group in the ITF, and also the Attestation Working Group in the Trusted Computing Group. He's authored over 30 industry standards for security and trusted computing, and he's co-authored a book, Demystifying the Internet of Things Security. And he's received the Trusted Computing Group's 2019 Key Contributor Award. And his interests include trusted computing, hardware roots of trust, distributed computing, privacy, and blockchain. So another very well-qualified panelist. And your turn, Ned.
Thank you. I've been looking at ICNs in terms of security for a little while now. One of the challenges that we're seeing in the industry is, as we mentioned earlier, having to do with, how do we secure the critical infrastructure? How do we secure, broadly across the internet, from the Internet of Things to the cloud? One of the interesting trends that's going on within that is something called zero trust, which is, in a nutshell, it's basically how do I prove to somebody else that the distributed platform that you're interacting with is worthy of the data that's being hosted on that platform? And it kind of it sort of goes against the grain in the sense that, with the trends towards cloud computing, containers, the goal behind a lot of that is to kind of decouple yourself from the hardware platforms underneath and focus on essentially a virtual kind of environment for your computing, so that you can get lots of portability across a variety of different platforms. The downside of that is we kind of lose the notion of, well, what are the protection mechanisms underneath? How do I know that the data that's being encrypted is encrypted with a key that's protected in hardware as opposed to in software? Those kinds of questions are sort of swept under the rug, and zero trust is a trend broadly within the industry to try and reverse that, but do it in a way that doesn't invalidate or negate the other goals of portability. So that's essentially a lot of the work that's been going on in the ITF is aimed at providing the tools, the mechanisms, the infrastructure for zero trust, and to make it broadly applicable and integratable. So as it applies to ICNs, I think ICN is largely a trend in the same direction that containers is, only it's focusing on data, and but you get the same sort of net effect of you kind of lose. You lose that focus on, well, what is the endpoint? What are the security properties of the endpoint? How do I know that the data is being protected? So that's what I sort of threw out there as kind of the problem space for ICNs and security, and how to resolve that is, I think, a great opportunity for this group and others to take a closer look at. And I can go on, but that's kind of the problem statement. I have some ideas for how to go about it, but I echo Eric's comments earlier about it really is the key, but the key is so much more than just the key, and maybe I'll leave it at that. But yeah, that's kind of the interesting area here is how can we bring attestation into the data world. So think in terms of attestable data and provenance of data. How do we address those challenges around knowing that the data is trustworthy because we know where it's been and who's been able to touch it.
Okay, so I don't see Dan. I'm going to skip over him unless he's showing up there. Okay. All right, so Christos, you're up. So Christos is a professor at the University of Memphis. He spent 2 years as program manager at DHS S&T, managing projects on cyber physical system security, and his interests include NDN applications, internet measurements, and security. And he's currently investigating the application of NDN to vehicular networks, which is quite interesting. Okay, you're up, Krista.
Thank you, Kathy. So as Kathy said in my intro, I've always been interested in NDN from the application side, because I think we've got a lot of great teams working on how to make NDN better, how to make it lighter, how to make it more secure, and so forth. But I thought we always needed somebody to work on applications. Started several years ago looking at scientific applications, and the need there was huge data transfers that the scientists wanted. And NDN obviously has a lot of great mechanisms to efficiently transfer data, transfer it from multiple repositories, and so forth. More recently, I was interested in looking at what other applications in NDN we have, and applications that may have more security requirements. Scientific data do have security requirements. For example, imagine if somebody breaks into your climate data repository and start messing up with the data. You know, the political implications of that would be terrible. But more recently, I was thinking that a domain that is looking for applications where not only data efficiency, but also security is super important, is the automotive space. What is going on in the automotive space is that they are moving from essentially primitive networks such as CAN and LIN into automotive Ethernet. And all of a sudden, the world has opened up in front of them. They're looking at it saying, wow, we can do gigabit per second data rates. We can actually put in security in these data networks, something that we've never had with our automotive networks before. And I am looking at them, and they are clearly looking at the IP stack as the solution to all their problems in terms of moving it into the automotive networks. And I'm thinking, wow, wait a minute. We already know that there's problems with the IP stack, especially in security. You guys are about to take all the problems that we created and port them into vehicles. And it should be pretty clear why that's important. Vehicles are getting more and more connected. The safety systems, in addition to entertainment systems, are beginning to integrate. Your brakes, your steering is going to run on these networks with IP security. Autonomous vehicles will be running over automotive Ethernet and maybe the IP stack for security. And I think I'm preaching to the choir here in terms of saying that this is kind of scary. If they at least need to be aware of all the problems, security problems that we've identified with IP, and at least begin to look at alternative architectures such as NDN. So I could go on for a while in terms of explaining why I believe NDN is very suited in these environments. Very quickly, they have lots of different data rates, anything from sending a signal that is 8 bytes to tell you that your window is down, all the way to uncompressed video from cameras on your bumper that is used to guide an autonomous vehicle. They, at least in the near future, they will have a variety of networks, different types of networks, going all the way from simple networks such as CAN to automotive Ethernet. They have vehicles that will be out there for a very long time, 10 to 40 years. They have communication that ranges between communicating inside the vehicle as opposed to, in addition to between vehicles with V2V, and also vehicle to the cloud. And they have a lot more applications that are being developed. So all of these are things that we have demonstrated that NDN will do, can potentially do well. So, I think now is the time to talk to your automotive community while they're still searching for appropriate solutions for vehicles, and see if we can have any impact. Okay, that's it.
Okay, thanks, Christos. You might get more questions on that later. Okay, so I'm going to move on next to Jan. And Jan Seedorf is currently professor for IT security at, I'm probably going to mess this up, the Hochschule für Technik in Stuttgart. And he's chair of the IETF application layer traffic optimization working group. And he's been researching ICN for many years. For example, in the Green ICN project and also active in ICN-RG. He wrote an RFC on using ICN in disaster scenarios. His current research interests are ICN security and IoT security. And for example, investigating object encryption versus channel encryption and corresponding crypto schemes such as attribute-based encryption or homomorphic encryption. And that's actually pretty interesting, right? Because the object encryption is really kind of a feature, and it's one of the reasons we think about going to ICN and being more secure. So, okay, your turn, Jan. Tell us what you're thinking.
Thank you very much for the introduction, and I'm actually happy to see here many people from the Green ICN project actually as participants. It has been a while. I hope we can see each other face to face again in the near future. So one of the questions that was circulating around in the email thread on preparing this panel was, is ICN actually more secure than IP networking? And I kind of zoomed in on that question when I prepared my thoughts for this panel. And one of the things that I think we all know is very different, and I want to talk to Ned about that later on during this panel, is that, of course, with ICN, the vision from the beginning was that you don't have this channel encryption like we have with TLS, but you have the vision that you can encrypt the objects, and you can sign the objects, and then whoever gives you the data is actually what cache or what node gives you the data. You don't really care, so you don't have to trust that node. And with NDN trust schemas, I think we have a very suitable solution for signatures. I don't know if all of you are aware of it. I mean, there was a tutorial here this week. So I assume that people are aware of it. In a nutshell, you can put a schema out there and you can tell who is allowed to sign what object, which is kind of like a certificate pinning in the IP or in the current web world, where you can actually say, okay, only this person is allowed to sign that data. What is fundamentally different, and that's why it's very hard to compare IP networks with ICN networks, is that not only does that mean that you have object encryption versus channel encryption, but you also have kind of a separation between signatures and encryption. Because in the IP world, TLS does both. I mean, there has been a long discussion of encrypt first and then do the MAC, or do the MAC first and then encrypt, but essentially does both at the same time. And TLS, by the way, is very successful. It's a big success story for, fostering encryption in the IP world. So TLS is basically solving that problem for the web, if you want. And in ICN, you have this difference. I mean, if you go back to the vision I was just talking about, you would want every node in between to actually verify a signature. That doesn't mean that you can do that per packet or every node is supposed to do that, but essentially intermediate routers are supposed to be able at least to verify signatures. And again, with NDN trust schemas, you can do that. But the encryption, you want it in a way that, of course, intermediate routers cannot decrypt for most scenarios. And so you have this kind of separated. And I think this is one of the differences that also has that means there are two different areas actually to explore, and that's why it's very hard also to compare it, but also that has been kind of because it's also intertwined with the whole communication protocol, the encryption. It's kind of on top, and that's why there have been many people working on different solutions, and there's not this one single encryption stack, for instance, for NDN. And those were kind of my thoughts. And I mean, one of the questions that was asked in preparing for the panel is, how could you move this forward? I actually have been working in this area. And if you look at IoT in the IP world, a lot of people are also now thinking about not encrypting the communication channel, but the object itself. And attribute-based encryption, for instance, is one way of doing it, but also with just regular symmetric encryption, you can do that if you get the key distribution problem right, obviously. So one way I think the ICN community should work forward is work together with these people in the IoT world, basically, whether it's ICN or IP is actually is both need the same thing. They need object security for many scenarios. So we should work together with these guys, and we should also foster more crypto stacks for IoT operating systems that actually, offer this kind of advanced crypto schemes I was just talking about. Because for many IoTs and NDN scenarios or ICN scenarios, they're very useful. They're out there, but there's not this one crypto stack that everybody's using for that. So again, so I would like, in my view, there's a separation of signatures and encryption. I was just talking about signatures, in my opinion, is kind of solved with the NDN trust schemas, but encryption, we have many ideas out there, and for many years, I mean, when I started looking at ICN security almost 10 years ago, people had already written papers about attribute-based encryption by ICN, but it's still at a research stage. So there's not this one crypto stack that everybody's using and that is available on top of NDN in an operating system. So those are kind of, but this is also my research area. So of course, this is where I have a clear opinion on. So as the others, I will stop here. And the last thing I maybe want to say is when we talk about zero trust, I always had the vision that zero trust is kind of inherent in ICN because from a security perspective, because ICN from the start had the vision that you don't have to trust the host that gives you the data. You should not be needed to trust that host. You can just get the data and then you verify the signature yourself. And of course, if the data is encrypted in a way that only the people who are supposed to read the data can decrypt it, then you basically can store also the data wherever you want. Yeah, so I stop here, and those are my thoughts for the beginning of the session.
Okay, I think that's great, and I'm really glad that you did introduce this notion of the fact that the security is different, the object-based security as opposed to channel-based. And I think it's also really interesting that you're saying that that might be something that could be used between the IP world and the ICN world. But I also kind of, this notion that zero trust is somewhat inherent in ICN, and I think I find myself kind of agreeing with you, but I'd like to know what Ned thinks, since, you know, he kind of comes at this from the zero trust and the IP world.
Yeah, so I kind of disagree in the sense that the term zero trust doesn't mean that, hey, I don't have to trust anybody for anything anymore. It means that you have some explicit description of what you are trusting, and for the things that you and to essentially reduce the things that you trust implicitly to the smallest attack surface that you can. And we have some terminology called the root of trust, which is essentially this idea that there's some sort of kernel or core component in your system that you trust implicitly because you have to. And there's there continues to be a lot of interest in sort of defining roots of trust to be more and more constrained. If anyone's familiar with the Trusted Platform module called the TPM that TCG has been working on for 20 years or so, they refer to the TPM as a root of trust, but in actuality, it's a fairly large IC, and there's lots of attack surface there. More recently, the TCG has been defining something called DICE, which is an acronym for Device Identity Composition Engine. And this is a much more constrained root of trust. Initially, DICE was targeting IoT because of the constrained environments that exist in IoT. But what we found is that the server world is a bit like IoT, in that the servers have the various components within the server environment are looking for cost reduction opportunities, but still preserving security. So it turns out that DICE is a technology that's being integrated into server platforms as well. And the server platforms are starting to look a bit more like an IoT network underneath the covers. So you kind of see this evolution of the platform into ever smaller components that are truly trusted. In other words, they're implicitly trusted, and everything else is explicitly trusted in the sense that there's a process for identifying what it is, what it's composed of, identify the firmware, identify a version information, and track that. You might even track it through the supply chain to make sure that there wasn't some sort of supply chain attack that was applied to it. And so this is where attestation really comes into play. Is it's providing the mechanisms for explicitly keeping track of what it is that you depend on in your computing environment for security. And it goes from the hardware layer through the firmware through into the software layers. The challenge is how do we remove how do we simplify the size of that trusted component so that we can get back to trusting the data? And so there's technologies that are out there and emerging where the focus is on trying to reduce the size of the kernel for applications so that you just have your own little, each application can have its own little secure environment or enclave. So examples of this are ARM's TrustZone, Intel's SGX, and hardware that is providing, direct, support for containers. Those are kinds of the trends that I think are interesting. And so from that perspective, the way I think about security and NDN for Zero Trust is I have my data is protected by a key, the key is protected by an enclave. And so before making any decision about the data, I want to check the trust entailment of the data. So I want to know what key am I trusting? What keys are being used? What are the security implications of the key management system that's being applied to the keys? And then how are the keys protected? And so I think that's kind of the challenge. That's the big challenge that we have in NDN.
Okay, and it sounds like it came back to keys. We have a question on the chat, but I wanted to give the other panelists a chance to kind of react to what you've said. And Jan.
Just a quick comment. So thanks for the explanation. I now understand more what you actually mean. I have to admit, when I was talking about Zero Trust, I was thinking mostly about encryption and or an encrypted object. And like I was saying before, when the object is encrypted such that only people who have the corresponding key can decrypt it, I don't care so much about the server who's storing that data. I care mostly, but then of course also TPM and the whole software attestation comes into play. I think about my client being able to verify the key that I'm using is correct and my system is, from a software attestation perspective, correct. But of course, talking about signatures, of course, every router on the way, like I was saying before, should be able to verify a signature, and then that router needs to be able to do attestation that the key is the correct one and everything. So I understand what you're saying, and I agree. I was just saying if you just look at encryption of the data, I don't really need to trust the server that I get the data from if the encryption is correct. That still means I need to verify that I have the correct key and that my system that I use, my client system for decrypting the data is, of course, uncompromised and so forth. Yes.
Any other reactions on the panel? I can go to some of the questions over here. First, I guess Randy King asks, he says he'd be curious if there are aspects of ICN that are at odds with the goals of Zero Trust. Any thoughts about that?
Yeah, absolutely, there are. The things that are at odds with it is privacy. So attestation fundamentally is trying to expose or take information that's hidden and make it visible. And a lot of times that information is very detailed. There's a lot you can learn by sort of analyzing the attestation information about the physical layout of the network and so forth. And so there could be privacy considerations to take in, to look at. And so that's a big problem. They're sort of at odds. And I sort of see that generally across any network is privacy is often at odds with the goals of security. So that will continue to be a challenge going forward.
Okay. Anybody else have thoughts? Anyone on the panel?
So I think that zero trust is really resounding all around the world. I mean, the White House just issued an executive directive about how that's going to in part pervade the security posture for the government going forward. And so I think it sort of covers a lot of ground when you say zero trust. And I think there are lots of ways in which I think NDN can really effectuate sort of a fundamental answer to, like, for example, zero trust architecture. You could construct, I mean, if you start talking about object security, which I think is exactly the right direction for a lot of ICN work to go, I think you get a lot of fundamental building blocks to build zero trust architectures, zero trust solutions around protecting the data, and you're less concerned about the network topology. I think that was kind of implicit in what I heard going back and forth a second ago between Ned and Jan. So I think honestly, it sounds a lot like a lot of agreement over the sort of the broad strokes. And to my money, I think NDN is very well positioned for that. And I think this is another case where it's sort of looking at the woes of today's IP architecture helps illustrate some of the benefits that an ICN architecture is in a position to provide if the research goes that direction.
Yeah, I think maybe this sort of fits a question from Dave Aran from the Slack channel, which it's a little long, so I'll try to just pull out. He's sort of saying, well, because in ICN we're focused on the object security, that will switching to ICN make it more feasible or easier to incorporate data provenance into the network architecture, so every application doesn't have to create something custom or completely ignore the problem. Any thoughts?
So I think that goes straight at what Ned was just saying. I mean, at that point, I think Dave brings up a really good point. It sounds like the promise is totally there, but then you've got to reckon with exactly what I think I heard Ned saying a second ago, which is that, to do the inspection necessary to build provenance for whatever you're talking about, whether it's a traffic stream or some sort of document objects, then you're exposing where it's been or what aspect of provenance that you want to codify. So I would predict that there'll be a tussle there, but I think it's a healthy tussle to have.
So if we sort of take a retrospective on IP networks, some people are familiar with the hourglass analogy, which is to say IP is sort of at the center of an hourglass of technology, and above and below it, it's the hourglass sort of gets larger in terms of the complexity and in terms of proprietary solutions. But IP was a very important component in that hourglass, because what it did is it made the network open, and so that meant we could get a lot more. We could increase the size and therefore the value of the network because the network protocols were open. And what's happening is the openness is moving in both directions. It's moving up and down to sort of narrow the range of choices, because as things become more open, people then are able to align with those open technologies. And so the range of possible choices is smaller, but that also means there's greater interoperability. And it's the interoperability that provides Metcalfe's laws sort of, predictions of value. Metcalfe predicts that the value of the network increases as the number of connection points increases. We sort of apply that to that hourglass kind of analogy. Essentially, we're seeing the forces are sort of slimming the hourglass, if you will, from the center and moving up both to the top and to the bottom. And what that sort of, to translate back to sort of ICNs, is what we're seeing is essentially open data, right? So the more the data becomes open, the more interoperability we'll have at the data layer. So in security, we think of, hey, we need to have end-to-end protection, end-to-end encryption, end-to-end integrity, whatever, right? End-to-end access control. It's just a way of saying, hey, we need to have the focus of security at the data level. Now, security community is very resourceful. And so when IP happened, the security community said, oh, we need security. Let's apply security at the IP level. Right. And so as we see openness being applied, further up the stack and further down the stack, we're going to apply security in those areas as well. And so that sort of seems like ICN is sort of positioned in the right spot for security to take advantage of those trends towards open data.
Okay, so in other words, we put security at the IP layer, and that's how we kind of got channel security. And you're saying we're moving towards the object, or
we're moving towards object security on the data side, and then we're on the hardware side, we're moving towards open hardware, which is another way of saying that we can factor out the IP stack from the context of zero trust and end-to-end security. We can sort of factor out a bunch of the stuff in between that sort of doesn't matter. So network topology became a security mechanism because that's all that was there. And so the security guys looked at it and said, oh, I can create a choke point at a router.
Yeah.
And so we had firewalls.
Yeah.
Okay.
Yes. Yeah.
But now the industry is moving on the hardware side. The industry is moving towards factoring out all the sort of the unnecessary hardware and system software, and focusing on things like enclaves. So Intel SGX is a good example, which is basically saying, hey, your application doesn't necessarily want to have to trust all of the layers of system software. There's virtualization, there's operating systems, there's device drivers, right? My application doesn't want to have to include all that inside of the trusted computing base in order to, do useful stuff. So an enclave is basically saying, here's a hardware bubble for which you can put your data, and you don't have to worry about trusting the rest of the system. Like, in other words, the virtual machine monitor, the various modes of the hardware, they don't have access to what's inside the bubble.
Okay, so it's a hardware bubble. I just want to see if there's any other reactions from any other panelists, and then we can go to some more questions from Slack. Anybody have something to say? There's an interesting question from Jay Misra, who says that he'd be curious to hear the panel's opinion on how you think ICN can help with edge computing. That there the data from the consumer can be worked on to generate inferences, and that could be sort of standalone or sold and used by the edge computing entity. And this could also be a multi-link process. And how do we create a provenance chain for that? He's asking. And there are some other things on that thread I can look at. Okay, so yeah, go ahead, Jan.
Edge computing is an interesting point, because I was mentioning before that TLS is a big success story in the IP world, but edge computing is actually the one thing where people now are essentially doing man-in-the-middle attacks to provide security, where they are, outsourcing. I think it's called SSL or TLS outsourcing, where the edge computer pretends to actually be the server, and that means it actually shares the same key with the original server, or all kinds of nasty stuff is going on. And that's a big problem for TLS. And there actually ICN is a big advantage if you switch to object security. Yeah, again, from my vision that I was mentioning before, you don't have to trust that edge at all. And you can actually, with end-to-end trust schemas, provide the provenance kind of, naturally, so to speak. So the edge is just another cache in the ICN world that you don't have to trust, that doesn't necessarily have to verify the data. You can do it yourself. So for me, that's a clear plus for ICN, because it solves this problem that TLS kind of has with intermediate ops, so to speak.
Do we get any other thoughts on that? I mean, yeah, go ahead.
So it's interesting because in the last couple questions and including this one, I think we're using terms that have been around for a while and carry with them different kinds of baggage. So you might assume one person's talking about one thing and we might talk at cross purposes. So like provenance is a great example, just to jump back one. When people talked about provenance in IP, a lot of it was about, traffic flows. What was the provenance of a datagram's transit through a network? And that's not necessarily the same thing as document provenance, which is literally about content and who authored it and what the chain of custody is, which is maybe more relevant if we're talking about object security. And certainly the concerns are different at that point. So in regards to edge computing, it's the same sort of thing. Edge computing is a really big deal in 5G and NextG because it enables a bunch of things. It's got very little to do with content and more to do with latency and stuff like that. So in one case, but what I heard a second ago is we were talking about TLS offload and TLS proxy, which is like a huge component of DDoS service markets and CDNs, where you actually want someone to do that for you. Or if you're in a corporate environment, someone's going to do intercept to, do HTTP proxying for, whatever inspection infosec function they have. So, all these things, I think if we're not careful, we can easily be talking right past each other. When we talk about something like, an edge-centric anything, are we talking about the security model? Are we talking about a low latency solution? Because NDN would be fantastic in like a 5G, NextG, edge computing, fog computing environment, because if somebody has data at the same GNode B that you're talking them through, you don't want to have to backhaul that information anywhere else. And NDN does that natively. But if you're having a security conversation about, a document author that's somewhere else, then that's a much different prospect. So I think it's really useful for us to be quite explicit when we bring these, charged topics up, because we could just miss each other's point.
I think that makes a lot of sense. And I struggle with that terminology myself because I've been trying to work on applications that are kind of contained and, sort of use the edge word, but I know that's not really an adequate word for that. But it would be really nice to have a more agreed upon terminology for that. Like specifically, thinking about what Ned said, I'm trying to think about a world where I'm not depending on that, saying, oh, everything has to go through this router at the edge so I can firewall things. Instead, I want to create these trust zones that are sort of their own thing. And, but yeah, what are good words for that? And I think you're bringing up a really good point that, I hate to see anybody get rat-holed in terminology. This happens at the IETF. These groups go off for 5 years so that they can agree on terminology rather than solving a problem. But, maybe there's just a few things we can stake out. I don't know, anybody have any thoughts about that? Like, what would be the most important things to get some common agreement on?
So one thing that I would really like to see is to look at all these terms and see which of these terms have meaning within a channel-based communication versus a content-based communication. Because I think, so what does edge computing mean if you're in a content-based communication? I don't think it means exactly the same thing as when you're in a channel-based communication. And I think it would be really wonderful if we could, maybe as a community, try to define the context of these terms so we can be in agreement.
Yeah, I completely agree with that. And let's see, we have a comment from Dave on the, he's saying that current edge computing complexes seem to be all based on explicit transfer of trust through curation, e.g. Akamai CDN does dynamic web content computation on behalf of the origins owned by their customers. I don't immediately see how ICN helps here unless you instead base all the edge computing on instantiating computing running inside the trust perimeter of the original data creator or owner. Are there any clever things to cut this Gordian knot? And Jay has sort of followed up with, what if we turn the origin on its head and started the consumer universe being the data source? Any thoughts from the panel? Should we just say that's going somewhere else. Well, I have another. Oh, go ahead.
So let me just throw something out there in terms of some more concept than anything. I try to think of data as a series of envelopes, where at each envelope you have the opportunity to apply security, whether it's access control, DRM, whatever. You could, but you could also provide confidentiality protection. So you essentially have is something like a Russian doll of dark network, right? So if everything was encrypted and all the data is essentially layered, then you sort of have multiple layers of encryption on top of the data. But what you get is sort of at some level the data is at the outer levels, the data is focused on things like infrastructure. How do I move it around efficiently? How do I cache it? That sort of thing. And as you get closer into the data itself, there's sort of like a DRM layer. Who owns the content? Who gets paid for the content? That sort of thing. Who's made changes to the content? But ultimately, the center of that is the data. But it's this really complex object. Naked data is useless. There has to be these other layers of context in order to do everything that needs to be done. And so I think that's really one of the challenges that I see for NDN is having this sort of rich representation of data that goes from not just the actual bits, but all of the layers in between that are there in order to satisfy the various goals and objectives for moving the data around.
Okay.
It's really just it's distributed data.
I think that's sort of an interesting view. But Jan has something to say.
Just one comment to Dave's question. Are there any clever things that you can do? I mean, from a crypto perspective, there's this thing called sanitizable signatures, which basically means a proxy or a cache or an edge computer, an edge router could modify the content, like you say, transcode it or whatever, like edge routers do for providers, and then make the signature such as the signature is still valid for the end client to vary. So the sanitized signature basically means the owner of the data allows certain intermediate points to modify the data, but the signature still works. Of course, that only works for unencrypted data, but from the data provenance perspective, or how you call it, that there is a crypto solution at least out there for that. And it's actually quite well known, and there are many schemes that seem to work.
Any other thoughts from the panel in that area, or following up on what Ned just said? Yeah, go ahead.
I think I might just want to, based on what I see in the Slack channel, just to sort of clarify, I think that there are certain discussions about what we could call edge computing that fit an ICN model better than others, and the one I was talking about is something along the lines of in mobile networks. And maybe Chris will agree or disagree with me about this, but it's sort of right up the alley of what I think he was talking about. If you have a user element, a mobile agent, and it wants to transact with another one, and they're talking through the same RAN, through the same GNOB, they're like right next to each other. A lot of the 5G, next G technologies say don't backhaul their communications to some processing center. Put a mobile edge cloud near them so they can actually transact directly. That's what I was thinking about as some things that fit maybe an ICN model better than others. That one seems to me to fit pretty well, because ICN would be very well structured to say data being transacted between these parties that are topologically near each other would naturally just flow back and forth between them. So that's a use case that's very different than some of the other ones we're talking about, like CDNs and content owners and authors. And those obviously have a different impedance. They fit to a different degree with ICN. I'm just saying there's some things that some of us would call edge computing that would benefit greatly from an ICN architecture. And obviously it's more of a strained fit.
Anyone else have anything they want to say on this topic, or or following up, or did I miss anything that anybody wants to say something about? So I have a couple notes that I think I'm sort of summing up. We didn't really talk a lot, but this came up. The keys are key, what Eric said, and I noticed that keys were mentioned by other people, even though we didn't necessarily talk about, a lot of ideas that we could use there. And the whole notion of object security, that this is becoming important in IP, and this is, fundamental to ICN. And I thought this notion of the interoperability and the waste and sort of thinking about that Ned brought up is something that we might all want to think about. Where do we need to be interoperable? But I also heard a lot of good ideas about, like from things like the Russian dolls, or the notion of Jan's notion of transcoding, that we don't necessarily have to expose everything to everyone. And then the other idea was that about terminology, because the terminology that we use may be different from the IP world, or maybe there's a few things we should nail down so that we make sure we're on the right track. So to me, these were a couple key ideas that I really heard out of this panel. Did any of you disagree, or had something that I missed that you think is key that, the audience should take away? Nobody disagrees. Okay, I guess I feel like we could wrap up, but I guess one thing I might like to hear, since we have just a few minutes, is that Jan had mentioned when he was talking something about this notion of that he wanted to maybe talk about with Ned later, and I didn't see that interaction come back. So what was the question that you?
No, actually I did. That was the zero trust question that the interaction we had. So, yeah.
So I would like to say more about the key topic if we have time.
Go for it.
So key management essentially becomes the infrastructure for the data, right? If everything's signed and encrypted, all the data objects are signed and encrypted, then management of the keys is a prerequisite to management of the data. So if we talk about data scalability and data distribution, then the key scalability and distribution has to be on par with the requirements for the data distribution and scalability. And so that it's this sort of dependency that's on keys that gets overlooked when thinking about the infrastructure that supports the data. Tends to focus on, well, just the data and not the keys. And so, key management has to change from what it is now into something completely different that is aligned with the kind of the shape of the data network. So what we have is something that's aligned with the IP network.
That makes sense to me, but it also brings up something that I think when we talk in ICN, we often talk about every piece of data, like the data that we send as being something that we're going to keep around forever. And at least the kinds of applications I've been looking at, I'm thinking more about, sometimes this is just communications, right? It isn't something that we want to be around forever. And especially when you think about IoT-ish things, turn the light on. I don't need to save that forever. So if I use a key on that, I don't really need to be worrying about how do I keep that key structure around forever, or if that's making sense.
Yeah. So think of key, the term is key life cycle.
Okay.
The point is to say the key life cycle should align with the data life cycle. So if it's short data life cycle, then it should be short key life cycle. If it's long data life cycle, long key life cycle.
Yeah, that makes a lot of sense. And an issue that maybe we didn't talk about with just in the remaining things is that Dave Aran wants to know if we could talk a little more about privacy. Do you feel that we've given that short shrift? Is there anything anybody wants to say about that, or could say about doing that in ICN? I mean, it seems to me that if we're using keys, right, we can use them to have privacy. So I don't know that we really ignored that topic.
What we want to look at is our group keys, right? So can I do group signatures as a way to protect privacy, but still have data integrity protected and authenticated? So things like the the zero knowledge proof, direct anonymous attestation, EPID, those kinds of things. And then, of course, homomorphic cryptography has huge potential to address some of the privacy challenges.
Can you say a few words about that? That's not an area that I'm really very well versed in, and I'm
So encryption is one way to address privacy. If you encrypt it, then the distribution has been focused, right? It's not open to everybody.
Okay.
So right. So, but often the case is that there's a group of folks that are involved in accessing the content, and so you want to encrypt it to that group of people. So homomorphic encryption is basically saying, hey, if there's a set, so if you go back to the Russian doll analogy where you have layers of data around your data objects, right? At one of those layers, there's going to be some peer entity that wants to access that data, but only at that layer. And so you want crypto mechanisms that can be layer specific. And so homomorphic can do that. You can essentially perform operations, algorithmic or arithmetic operations on the data without decrypting it. So that's useful, right? But it's, you sort of have to, it takes some work to kind of put all the pieces together. And if you're sort of relying on PKI and TLS and IPsec and whatever, those are not the right mental models to make progress, in my opinion.
Yeah, I think that these notions of layers could be particularly useful in ICN, so that there's layers that you might want to expose for your wider world routing that you don't really want to use like inside a particular zone of trust or something. So it seems like maybe that notion of layers is going to be kind of key if we're thinking about sticking things together in a more global network.
Maybe one comment on homomorphic encryption. I fully agree that it's very useful and very promising, and for many scenarios, very useful. The problem with homomorphic encryption right now is that it's just much more computationally expensive than others, regular cryptography. It really depends. I mean, what you mean with homomorphic, if you just want to have additive homomorphic encryption or fully homomorphic or somewhere in between. But the problem is then if you think about, like we discussed, that edge computers maybe do transcoding, or a router is supposed to do something to data and then, use homomorphic encryption, then becomes very, very computationally expensive. And also specifically on IoT nodes, it's quite expensive computationally. But that changes quickly as hardware gets more powerful. So I fully agree, it's very promising. But that's the main issue with homomorphic encryption. The schemes are out there, more or less.
Yes, so it's like hardware can be your friend, but the hardware community isn't going to move unless there's customer requirements, and so it's sort of a chicken and egg,
I mean, the hardware kind of naturally evolves and gets more powerful.
Hardware will be there. It's true, but you can also specialize the hardware for special purpose applications, right? So the idea that a general purpose hardware compute model is going to scale evenly across all different types of workloads is not the most efficient and effective way to get the best performance. So we're seeing a lot more move towards specialized hardware to address those requirements.
Well, I guess also the more expensive encryption might be used for documents or something that you don't have to decrypt and encrypt on the fly. But I guess, as Jan is pointing out, for IoT, maybe if you want to encrypt, turn on the light, right? We might want that to be something that can be done quickly and by a low-cost device. Is that sort of fair to say, Jan?
Yes, and it's definitely a very hot topic because the hardware gets more powerful every year, and schemes that 5 to 10 years ago were totally unrealistic to use at all on IoT nodes now are somewhat feasible, somewhat. And that means maybe in 5 years they will be fully feasible, even on, off-the-shelf custom hardware and not specialized hardware as that was talking about. I'm not saying that that's not very useful, but even on custom, regular, multi-purpose hardware, schemes that now are barely feasible in 5 years may be very feasible. So yeah, it's definitely a hot topic to investigate.
Yeah, I mean, I guess these more capable devices have been our enemies, right? Because people can take over a light bulb and then take over your network. So we need to make them our friends too. Eric, did you have something to say, or are we about to get ended here?
Oh, we might be about to get ended, so I can be skipped or I can be brief. But I think it was funny. Dave brought up a really good point at the very end that I think it was probably would take an hour to sort of discuss fully anyway, which is privacy. So, but I would sort of end where I started, which is I think that key lifecycle management is critical when talking about the types of privacy protections that we're discussing here. If I want to send you something, I need to know your key so I can encrypt it to you. The lifecycle of that key matters a lot. If you've thrown that key away just as I've encrypted something to you, I've just put it in the garbage can. Or if I've intended you to get it and hold on to it or look at it later. So this is one of those things where I think as we're starting to do object security in the IP architecture world, we're learning these things. I don't think we have a lot of muscle memory on this. And ICN being bought into it on day one means that whatever lessons that have been learned probably should be examined, but nevertheless, they're pretty early stage lessons. I don't think we've done this a lot. So I think there'll be some interesting times ahead as people explore different privacy architectures based on that type of protection. That's about as terse as I could be in the waning seconds.
Okay. All right. I guess I saw Ken pop up there briefly, and I want to thank the panelists. I'm glad that you all brought your experience and your thoughts to this, and it was really good and informative for me, and I hope it was informative to everybody else. But hey, we had a good time, right? So that makes it worthwhile. And okay, so I guess I will let Ken take over. And again, I really want to thank you all for participating.